This video is the third installment in the series, How to Use and Interpret Pontius Matrix version 41, made by graduate students at Clark University. In this video, we will cover how to calculate and interpret quantity, exchange, and shift intensity between two maps. We assume that you are familiar with the concepts of quantity, exchange, and shift as the three components of difference. Each figure illustrates a single component in its simplest form. For further review, please refer to the paper and video published by Pontius in Santa Cruz, which can be found by following the link in the description below. In this video, we will build on their work by comparing the amount of quantity, exchange, and shift difference to the total difference for each category. We will refer to this as the component intensity. We will use this 5-pixel example to demonstrate how component intensity works. The contingency table below shows the number of pixels in each category at the initial and final times. The total column refers to the number of pixels in the category at the initial time. The total row refers to the number of pixels in the category at the final time. The 2 pixels on the left demonstrate exchange between teal and purple. The 2 pixels in the middle create shift for purple because they show simultaneous gain and loss without exchange. The final pixel represents persistence. Now, we will find the quantity intensity for teal to demonstrate how component intensity is calculated. The first step is to count the quantity difference. Teal has 3 pixels in the initial time and 2 at the final time, so it has a quantity change of 1. Next, we count the total change for teal, which is 3. To find the quantity intensity, we divide the 1 pixel of quantity change by the 3 pixels of total change and then multiply by 100. This process is repeated for both exchange and shift for each category. The Pontius matrix automatically calculates these component intensities when the user puts data into the contingency table on the sample count sheet. The Pontius matrix produces 3 figures to illustrate the proportion of each difference component in the study area. The first figure is found on the overall components sheet. As a whole, the column represents the total percent of change in the study area. In our example, there are 4 pixels of change and 1 pixel of persistence. Therefore, the column shows 80% of the study area changed. The stacked sections indicate the overall amount of quantity, exchange, and shift in the study area. This figure is useful for finding the dominant component of change overall, but it does not provide category level data. When the column is stretched to show 100% of change, the stacked sections indicate the average intensity at which each component affects the study area. We can use these averages, or uniform lines, to compare the intensity of the components at the category level. In our example, the uniform quantity intensity is 25, and the uniform quantity plus exchange intensity is 75. These values can also be found on the figures data sheet of the Pontius matrix. The uniform quantity intensity is shown in cell L18, and the uniform quantity and exchange intensity is shown in cell M19. The 100% figure is not included in the Pontius matrix, but it can be produced by selecting the figure and changing the column type from stacked column to 100% stacked column. The second figure is found on the category components sheet. The x-axis shows the percent of difference in the study area that each category accounts for. The sections within each row show the quantity, exchange, and shift for each category. Notice that the orange and teal have the same amount of quantity change. Orange has a positive sign because it experiences a net gain, and teal is negative because it experiences a net loss. This figure can be used to visualize the quantity intensity calculation that we walked through on slide 3. In this case, we would take the quantity section of the teal bar and divide it by the length of the entire bar, and then multiply by 100. If we repeat that process for each section of each row, we will produce the component intensity figure. Now, instead of the x-axis showing the percent of difference in the study area, it shows the percent of difference per category. Removing the information about the amount of change will help us compare the intensity of each component for each category. Notice that the quantity bar is now much larger for orange than teal. This is because the quantity change accounts for 100% of orange's total difference, but quantity change is only 33% of teal's total difference. We also see that even though they have the same amount of exchange, the intensity of teal exchange is greater than the intensity of purple exchange. The uniform lines in this figure must be manually adjusted to match those values found in cells L18 and M19 on the figure's datasheet. In this example, orange and teal have greater than uniform quantity intensity. Teal has greater than uniform exchange intensity, and purple has greater than uniform shift. This concludes our overview of how to use and understand component intensity calculations in the Pontius Matrix version 41. To learn more about the Pontius Matrix or to download the Excel program, please visit the link in the description where you will find further videos and publications. Thank you for watching.